One. I guess it's the first time I meet you guys. Have some people in the room, one person online. That's great. This is my kind of weekly group sessions to support people with studying in statistics, data analysis, and then data analysis using a tool called the Microsoft Excel spreadsheet. So for this today, we probably finish around 1 something. I will introduce on how to calculate some commonly used statistics using Excel spreadsheet functions and formula. Can I briefly ask you what brings you here? Like what unit are you studying, or what unit are you using Excel at the moment?
I major in finance.
Finance, yeah. Okay, your first year in QT. Okay, how about you, lady? Economics. You are first year. Last year. Do you have any specific unit you need to? Okay, analytics. All right. And then we have one person online. How about you?
Business economics first year.
First year. Okay. So I guess, are you enrolled in any like BSB 131 or something like that?
BSB 107.
Finance.
Ability.
Okay. Okay. That's about investment something, right? Like that.
Yes.
Yeah. Okay. All right. So today's focus is about calculating. I call them summary statistics, because statistics is all about using mathematical tools to get insights from data or data, whatever pronunciation you like. Okay, so using mathematical tools to get insights from data. The data we are dealing with in statistics, we call them structured data. So it's like a numbers something, or things can be coded in numbers. All right. If you are analyzing unstructured data like text, video, images, audio clips, they are all data, but they are unstructured data. Okay, and we are not doing that. We are analyzing here. We call them structured data. The most commonly used structure of data is to organize data in a spreadsheet. Okay, if you missed my previous workshops, we just briefly covered that. So how to organize data in a structured way? The most commonly used structure is a spreadsheet or a form or table. Okay, but I like to call them spreadsheet. How to organize that into spreadsheet? Just think about the things you're trying to describe. Let's say I want to describe the students in my class. Then the units of analysis in this hypothetical study will be individual students, persons, people. All right. That's the first thing you have to get clear about for whatever analysis you want to perform. I mean, statistical analysis you want to perform. You have to be clear about the unit of your analysis. So suppose I want to know something about my students in my class, then the unit analysis is a individual student. If you want to analyze the stock markets, specifically the listed companies, then the unit will be listed companies in a specific market. For example, the Australian market or American market or whatever market. Okay, if you analyze marital relationships, then the units may be couples or households. Okay, it depends on the question of your study, the aim of your analysis. Okay, you have, first of all, you have the 100% clear about the unit of analysis. So suppose we are analyzing my students. The unit is individual students. And then how to describe a unit of analysis? Then how to describe a student? You have to know that one, okay? So how do we describe a person, a university student? We have to know their name, for example, age, in years, or sex group. Okay, let's get the simple, just make it sex rather than gender, because when it comes to gender, there will be lots of options. How about let's say major of a study? Anything else? Education. I mean something like let's say height. I don't know, for whatever reason they need to measure the height. Okay, or weight. So you need to know the features you want to analyze for your unit of analysis. Okay. Otherwise, we cannot perform statistical analysis. Okay. What features or what attributes or variables to include in your data set? It depends on the purpose of your study, the scope of your study, and also depends on most of the time the budget of your study, how much time you have to measure them. Okay. And how much money, how much resources you have to collect information from those features. Okay, so for any statistical analysis, you need to know first of all the unit of analysis and the attributes or features or the variables you want to measure or describe the unit of analysis in your study. So for this hypothetical example, the unit analysis is the individual students in my class, and then I'm trying to collect the data that describe these 6 features of every single unit student in my class. Okay, so I just type some fake names. So maybe first one's called Jim. Second is a girl called Jess, and then something Aaron, Ben, and then Haley. Okay, so suppose I have 5 students in my class. I have the information of the first feature, name. I can also get data from the second feature, age, like 16, 24, 17, 18, 20, 29, maybe 31. Okay. Sex, I just either male or female. No, I think Jim should be a male. Okay. Major, I just make them easy, like engineering, called ENG, business called BIZ, and BIZ, and okay, suppose we only have 2 majors here. And height, I'll put in some numbers, 180, 172, 167, 68, okay, 179, and Haiti is 168, 173, okay. Just ignore the weight, let's say just have five variables here. So the data, that's the most commonly used structure of a statistical data set. So we put the individuals of the units of analysis into the rows, and then we put their features into the columns, and then we form a spreadsheet. You can also call this one a table or form. Okay, but I like to call them a spreadsheet. This is a data set. Okay, and then if you have like a multiple units of analysis in your study, and then we can organize things into different spreadsheets. Okay, these are the students. Okay, I also want to know what kind of mobile devices they are using. Then I have a spreadsheet of, let's say, computers or devices. Okay, okay. And then if I want to know what cars they are driving, and then we can have a spreadsheet of cars. Okay, and then how to describe each car, it's up to you. Okay, colors, module, a brand, price, years. Okay, so that's how we organize data. So we group people, we group things of the same category, and we put them into one spreadsheet. If you have a multiple categories to analyze in your data, in your study, then we can organize different things into different in different categories into different spreadsheets, and then we can connect them. But how to connect different spreadsheets, that requires expertise of database management, which is a bit different from statistical analysis. Okay, if you are studying finance or information system, or even economics, you may come across some skills of database retrieval or query, and then you may have to learn something like a database management and modeling, if you like. Okay, there are many options at QUT and other institutions, but for me, I focus on statistical analysis of data in one spreadsheet. Okay, so once we know the individuals, the union analysis, and the variables, the features or attributes, how to use mathematical tools to get insights from data, there are two basic approaches. The first one is a visualization of data. You can create graphs, tables to get insights from data. The second option or second approach is to calculate summary statistics. That's the focus for this session in the next probably 45 to 50 minutes. Okay. So I believe you know something like a histogram, pie chart, or donut chart, bar chart, scatter plot, okay, box plot, frequency table, group frequency table. Those are the visualization tools. Okay. How about summary statistics? Summary statistics. Do you know any summary statistics from your? I'll give you something like a mean. What's mean? Mean means average. Okay. There are different types of means actually, but the most commonly used type of means is called the simple mean or arithmetic mean. It's used to summarize the data or information from one numerical variable like height or age. Okay, those variables are numerical variables because their values are meaningful numbers. Okay. The other type of variable is called a categorical variable because their values are just categories for like a major and the sex. Their values are just meaningful categories or group names or labels. Okay, we call them categorical variables. For the variables whose values are numbers, meaningful numbers, the numerical variables. A name is also a categorical variable because they're just the value is just names. Okay. Yeah. In case you have a values like for sex, sometimes we use like a 1 or 2 to represent categories. Okay, maybe 1 for male, 2 for female. Again, in this case, the sex is still a categorical variable because the values, although the values are numbers, are numerics, but they don't have a numerical meaning. Okay. 1, 2, they are just symbols. You can use A or B or F or M or A, male, female, or 1 or 2 or 0 or 1. Doesn't matter. It doesn't change the nature of this variable because the values are categories. They are not numerical. They don't have a numerical meaning. Okay, you can use numbers to code them, to code those categories, but it's still a categorical variable. Okay, they don't have a numerical meaning. 1 plus 1 is not 2 in this case. Okay, you can't get a female by adding up 2 males. Okay, that's why we say that they don't have a numerical meaning. Okay, yeah. Okay, that's the probably the third thing you have to know to recognize the variable types. The basic classification is a numerical versus categorical. Okay. There are also other types of classifications of variable, like a nominal, ordinal, interval, ratio, or whatever. But the basic, I think the most commonly used classification is distinguishment between numerical variables and then categorical variables. Why? Because we have a different sets of tools to get insights from numerical variables and then from categorical variables. Okay, for numerical variables, for categorical variable like a sex and a major and the names, there are a few tools. But for numerical variables like age and height, we have more mathematical tools because mathematics is most of the time about numbers. So we have more tools to use to deal with numbers. Okay, so let's think about a simple case for a categorical variable like sex or major or name. What kind of summary statistics can we calculate? Think about one. Major. I guess this example is probably too simple because we only have a. Think about this one variable major. We only have 5 entries here. We only have five observations. In practice, our human brains can deal with numbers below 10, right, or below 7. So we probably don't need any summary statistics. I just tell you, we have engineering, business, engineering for these 5 students. But imagine we have 5,000 cases here. We have one column, major, but 5,000, not 5,000, 500, or even 50 rows, okay? So we have like more than 10 entries. Human brains start to kind of freeze. Okay, we can't deal with numbers more than our numbers of fingers, to be honest, for most human beings. Okay, so when it comes to numbers larger than 10, we get confused or overloaded. So now we need to use some tools to get data, to get insights from data. So the numerical tool for a categorical variable like a major, the most commonly used one is called the frequency. The frequency of each category of each value. Okay, so first of all, you need to know how many values we have for this categorical variable. Okay, what are the distinct values? For in this case, we can know that it's easy to see. We have 2 values, major for major, engineering and business. We have a long list of this variable. You can turn on the filter. You go to home, you turn on the filter here. This one. No, this one, filter. Okay, you go to home and you can turn on the filter. And then Excel, if you open this drop-down menu button, Excel will list the distinct values. You can also choose to view some and hide some. Okay, if you need to. But use this option, use this function cautiously because sometimes you turn on the filter and then you close the file, and the next day you may forget you have the filter on. And if you're sharing the file to work with other people, that will be another disaster. Okay, so use this option, this function cautiously. Okay. Okay. Otherwise, there's a new function in Excel called unique. So if I want to get the unique values of a column or a range of data, I can use a function called unique. So whenever you use that function in Excel, you go to the cell you want to place the value from the function, and then you start typing equal sign. When you start typing equal sign in a cell, in a spreadsheet, it tells Excel, okay, I'm going to use some formula or function. The function I'm going to use is called a unique. You may or may not know it's a new function, unique. Unique. Okay. Every function has a name in Excel, so this function's name is called unique. And then you open the brackets. This function requires some inputs. First of all, it requires an array of data. It can be a row, it can be a column, it can be a a square range. Okay, for me, I just want to know the data from this column. Okay, this is my real data. Okay, and then if you close the bracket and then enter, Excel will list the distinct values from this range of data. Okay, this unique function is a new one. Is a new function in Excel. When you have a more than one unique values, the unique function will return the values in a column. Okay, so here we have a two values. So unique function spit out two results. I mean, two values in a column, engineering and business. You can see here, if I highlight H2, this is the cell where the function is. You can see I can edit my function in here. But if I highlight the other cell, H3, it's grayed out because H3 is taken by the results spit out from H2 formula. Okay, yeah. So this kind of function unique. It's called a dynamic array function in Excel. Microsoft just released a couple of years ago. Okay, I think it's very useful. Yeah. If you want to, like, if I change my value, I range from like D2 to E6. Okay, what will happen? Just give an imagination. What will happen? We get engineering, we get the business, we can also get the unique numbers from column E. Oh, hang on. I will return the unique rows by the combination of these two variables. Yeah. But if we want to get the unique values from the entries from multiple columns, first of all, you need to put them together. You have to put this column here and this column here. You have to put them. You have to wrap them together. We have a function for that in Excel. I think it's called a wrap or something. Wrap rows and wrap columns. You can explore later. Okay, that's not in my agenda today. Okay, but this wrap row or wrap function is also a new one, probably just released last year or something. You can have a look at this one. Wrap columns, wrap rows. Have a Google or have a YouTube chat search. This two are also new function, just released probably a few months ago. Yeah. So if you highlight multiple columns in Excel and then use a unique function, Excel will return the unique combinations of the values from the columns. Yeah. Okay. And then if you want to put them in one pool, you have to wrap them together first. Okay, but that's probably kind of out of topic. Off the topic. So for a categorical variable, the most commonly used summary statistic is the frequency of each value or each category. Okay, so we can get the unique values of a categorical variable using the unique function. Okay, yeah. Or turn on the filter. Okay, or we can use something called pivot table. Okay, so once I have a data like this in a block of data, we can build a pivot table on top of the data or based on the data. So you just have to highlight any single cell of the data set, any one of them, okay? And then go to insert a pivot table here. Okay, just highlight any single cell of the block of data you have, go to insert and the pivot table. Excel will by default recognize the block of data, and then by default trying to put a pivot table into a new spreadsheet. I'm okay with that, so I'm click OK. So that's my pivot table, a draft pivot table. Okay, and then once you click on the pivot table, this field list will show up here. It's called the field list, a list of fields. Your arrangement, maybe you can click on this setting button to change the layout of your field list. Okay. Now, what I want is I want to have a list of the individual values of the variable major, and I also want to count the frequency of each value. So in this case, I just use the default. But that's the default layout of a field list. So I'm going to put a variable major. I drag it into the rows. You see, pivot table will show up the. It's like the unique function. Pivot table will list the individual values into the rows, and then I can drag the same variable into values. And then when it says count of the variable, that means the frequency of the values. So I have a 5 rows in total, and the 3 of them showing the value engineering in the column major, and the 2 of them show the value business in the column of major. Okay, and if you left click this variable, you put into the value corner, and then you can choose value field setting. We have 11 built-in functions here. For this variable major, we don't have much to do because you can't calculate the mean or standard deviation or whatever. You can only request the counting, the frequency. Okay, so frequency of the values or categories of a categorical variable, that's the most commonly used summary statistic. So we know that in this little toy data set for this variable major, I have I have 2 engineering, business students and 3 engineering students, which is kind of ridiculous, right? For this case, because this data set is so small, but if you have like a 500 rows of even 50 rows, this pivot table can give you a very quick summary of the information in this column called the major. Okay, you can further calculate the relative frequency. Relative frequency is just the proportion. So how to do proportion? You can go to a pivot table and then right click. You can request show value as percentage of grand total or column total. Okay. Now we have the proportions. 40% business students, 60% engineering students. Okay, so right click, show value as. Summarize value as is just like the value field setting. You have a different calculation you can request. Show value as is about showing proportion or difference or whatever. Okay. And if you don't want the decimals, you can go to the highlight the numbers and go to home and then reduce decimals. This is about the decimal. This little button is for controlling the decimals. Okay. You can also insert a chart based on the pivot table. You can have a bar chart. Okay. Or you can have a donut chart. I think donut chart is replacing pie chart these days. The pie chart is kind of hard to read. I would prefer donut chart. A donut chart. Because what we are trying to illustrate here is just the proportions of the categories of the whole group. Okay. Pie chart is kind of out of date these days. Donut chart is more popular. Easier to read, right? You may ask me, what are the buttons here? These buttons, they call field buttons because I built this chart based on this pivot table. So this chart is by nature a pivot chart. Pivot chart is a dynamic chart. You can do something with this field these variables, we call them fields in computer science, in IT. You can even manipulate them here. If you don't want the gray ugly button showing up here, you can go to click the chart. You see here, pivot chart analyze tab show up, and then turn off the field buttons. Those buttons will disappear. If you want them back, go to pivot chart analyze and then turn them on. I guess in your report or PowerPoint presentation, you probably don't want them, so you turn off. Okay. And then there are many options for you to beautify your chart. You can change the color. Okay. You can change the shade of color. You double click. You can change the size of the format data series. You can change the size of the hole of the donut. Okay. You can rotate the angle. I don't want to explode it, just keep it tight. So many options in Excel data visualization tools. Okay. And they're very easy to use because whatever you click is the thing you can control. You don't have to use any formula or syntax or coding. You just click and then change it. Okay, it's easy to see. It's very direct. Okay, yeah. Right click format data series. As you can see, change the whole size. So for the pivot table, I just want to tell you one thing before we move on to the numerical summary. For pivot table, you see, whenever I click the pivot table, the field list will show up. But in case sometimes you need more space in your spreadsheet, you probably accidentally close the pivot table field list by clicking this button. If you close the field list, now if you click the pivot table, the field list will never show up again. How to get the field list back? You have to click the pivot table first and go to pivot table analyze, and then turn on the field list. Okay, yeah. So if you accidentally close the field list, don't panic. You can always get it back by click the pivot table first and go to pivot table analyze, and then click the field list. The field list will come back. Okay, yeah. All right. So for a categorical variable, not much to calculate. To be honest, frequency and the relative frequencies are the most commonly used summary statistics. Okay. You may have a more complicated table. You may have two variables like you can also drag sex into columns. Then you have a contingency table. Okay. If I drag sex into columns, then I have a contingency table. Okay. Sex in columns, measure in rows. I can see, okay, among the females, I think one is a male or two is female. Can't remember. One is a male, two is female. So among the males, you can highlight, you can change this one. Okay, this one's M. And this one will become M. So you can request the proportion into columns, or you can show value as proportion into the row total, or just no proportion, just show value as a frequency. Okay, yeah. So we call this one contingency table or two-way cross tabulation. You can see the frequencies of the combinations of the row categories and the column categories. And then the chart, this is a very cool chart. We call this one multi-level donut chart. It's a bit complicated, so maybe not this chart. You can use 2D column chart. Okay, or clustered bar chart. The terminology is not unified. So different textbooks, different tutorials, different people may call the same thing different names. So you can have a side-by-side bar chart. You can also choose to have a right-click, change data type, chart type. You can also choose this one, stacked bar chart, or you can also choose to have a percentage stacked bar chart. It's up to you. Okay, you design the information you want to visualize. Okay. All right, that's enough for the categorical variable. But what if your variable, the attribute, the field, is numerical, like a height? We can also use summary statistics to calculate, to get insights from the data. But in this case, it's too simple. We only have 5 numbers. Our little brains can handle it. But in case we have 50 numbers or 500 numbers, 5,000 numbers, it's hard to get information by just reading these numbers, right? So we need to calculate some summary statistics. For example, the mean, simple mean, the average value. Okay, so on average, how tall these students? The formula is just called the start with the equal sign first. The formula is called average. Average. You get a hint from Excel. Returns the average of inputs. Okay, so double click, and then you highlight the range of data. The range can be a column, can be a row. It can also be like if you have 2 columns, it's okay. It can be multiple columns. Okay, but in most cases, we organize data into columns for variables and rows for individuals. So most of the time, maybe 1 column. Okay, and you close the bracket. That's the average. The average has 174.4. So if you highlight the range of data, Excel will calculate average for you at the bottom for you automatically here. You can see here. Which is the same as the average function return. Okay, so that's we call average is a central value, central location of the numerical observations in your data set. Okay, and what's the formula for calculating average? You sum them up and divide the total by the number of items. So in this case, if we sum up these guys and divide the sum by 5, we get a 174.4. And of course, there's a sum function. If I type equal sign sum, that's the sum up function. And you sum up them, and then you divide the sum by the number of them. How to get the number of them? You use count, count. You get the same thing, right? You can expand the decimals into 10 decimals. They are exactly the same. Okay, that's mean. Another commonly used summary statistic for central value for numerical variables called the median. The formula is called equal sign and MEDIN, median. Again, you highlight the numbers you want to calculate median, and the return. That's the median. What is median? What is median? The middle value, right? The middle. What is middle value? You have to rank or sort your numerical observations, let's say from smallest to largest, and then you find the middle location, and then the value around that location we call the median. Okay, so here we have only 5 numbers here. We can sort them from smallest to largest. How to sort them? Don't highlight the whole column, just click one cell of the column you want to sort, and then right click, sort. You can sort from large to small or small to large. Let's sort from small to large. When you click sort, Excel will sort the rows according to the values in this column. Okay, so I didn't just sort this one column. I sort the rows by the values in column B. So I sort individual people by their height. You don't want to only sort height but keep other columns unchanged, in that case, you will mess up the data. You cut the connections between the column E and the other columns. All right. So when I just highlight this cell in column E height and then right click sort, I'm actually going to sort the individual rows, the people here, by their height value. Okay, that's what I want. Okay. You see, okay, after sorting them, you can see the smallest height is 168, largest height is 180, and then we have 5 observations here. The middle number will be number 3, and the number 3 person's height that will be the median. That's how we calculate median. If you want to do it manually, you sort them from small to large, and then you find a middle location, and that location's individual's value will be taken as the median. So in other words, I can say, okay, in this data set, half of the observations are in height is lower than my median, 173, and the other half is higher than my median, than the median value, 173. Again, for this toy example, it's kind of redundant, but imagine you have a 50 or 500 or 5,000 cases, the median can give you some insight about the general level of the quantity in this variable. All right. How about have a 2 in the middle? If we have a six students, then we don't have a middle 1, we have middle 2, the number 3 and number 4, and then we take the middle 2, and then calculate their average. That will be the median. If you do it manually, okay. If you do it manually, okay. Median, mean. Any other thing? Mode. Mode is the most frequent value in a data set. For numerical variable, it's kind of useless because very often we have a large set of numerical observations of a numerical variable, and they are very, very different. So you may have 100 observations, and they are of 100 different values. In that case, the mode function will not work properly. But if you have a lots of repetitions, like we have a 1, 1, 2, 2, 2, 2, 3, 3, 4, 4, 4, and then if you use the mode function, the mode will return the most frequent value or values. Okay, so let's try this one. Mode mod and mode single, there are 2 options. Mode mod means it will return multiple values if those values have the same frequency, the same largest frequency. Okay, mode single will return only the 1 value. Okay, so let's try this for column E. What will happen? I'm not quite sure. I get error because they are all different. They're all different, right? But if I change it, if I change this one to 168 again, okay, we have a 2, 168, 173, 179, and 180. And let's try the mode again. I try the mode, I choose the multiple, and then choose this range of data. I'm expecting to show 168. Yes, it worked. Okay. Because 168 is the most frequent value in this little data set. It appears twice. Okay. If I have a 168, 173, 173 again, and then the mode.mult will return both 168 and 173 because they both have the largest frequency, 2. Okay. But if I use mode single, I guess we only get the 168. Yes, only get the first line. Okay. Yeah. But again, the mode statistic is probably not very useful for numerical variable. As you can see, like if you're analyzing the household income, you surveyed 100 households, they may have a very different values. They all have different household incomes, right? Unless you round them up to 10,000 or 10,000, they have some repetition. But in most cases, the numerical values are very different in a data set, so the mode function is not very useful. Let's show them here for you. Okay, so after knowing the central location or central value of a set of numerical variable, you may also want to know the spread. So how different they are. Okay. again, we have some mathematical functions we can use. The first one is called the range. What is range? For statistics, range is a special formula. The range is called the difference between the maximum and minimum. That's called the range. Okay. So there's no range function in Excel, but Excel has a minimum and maximum function. So we can take the minimum and the maximum separately and then take their difference. So the minimum is just called MIN, and the range, the data range is here. So we can see the minimum will be 168, and the maximum will be MAX. Okay, and then the range will be easily. There's no range. Oh, no. So will be maximum minus minimum. For this data set, the range of variable height is 12. The difference between the smallest and the largest value is 12. Okay, so range is a useful statistic to summarize a numerical variable. Okay. We can also calculate something called the standard deviation. Okay, it's called STDEV. If you study in finance or economics, you will never avoid this formula, standard deviation or variance. What is a standard deviation? You have any idea about that? What is standard deviation? If you don't know or if you can't remember it, go back, check your textbook. Again, standard deviation is very hard to say in one sentence because the formula is a bit complicated. It's not like an average or median or range or minimum or maximum. We can easily tell people what standard deviation means because standard deviation is calculated in a funny way. Standard deviation is calculated as the square root of variance. Okay, I'll show you the numbers first. So let's calculate variance first. Variance is from the variance, VAR. That's the variance formula. VAR. Again, we have two options, either VAR.P or VAR.S. I'll tell you the difference later. So let's calculate the variance for these 5 numbers. The variance for these 5 numbers is VAR.P and then the range of data E2 to E6. It's this. It's 19.44. Okay. And then let's calculate the standard deviation of these 5 numbers. STDEV.P. Again, like a variance formula, we have 2 options, either .P or .S. I'll tell the difference first. Just choose .P now, for now. Okay, and then we highlight these 5 numbers and then enter. Okay, this 4.4 blah 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 is the square root of 19.44. If you can double check. Okay, if you go to this cell, how to calculate square root? It's called SQRT. SQRT. Square root. SQRT of 19.44. I can guarantee it will be 4 point something. Okay. So standard deviation is a variance. Is a square root of variance. But what is variance? What is variance? If you remember variance. So variance is kind of a relatively easier to interpret or to explain. Variance is the average of the square differences from the mean. Okay, so for these 5 numbers here, first of all, we calculate the mean, 172.4, and then we calculate the difference from each value, from each observation to the mean. Some will be negative, some will be positive. All right, so let's do this one. So the difference will be this one minus the mean. So for the first observation, the difference from the mean is a negative 0.44, 4.4, because it's smaller than the mean, so it's negative. I can drag this formula to the other rows, but before I do that, I need to make sure I lock the reference to the mean in row 2. If I just simply drag it, you see what happens. The first one is okay. E2 minus G2. If you double click, you get the formula E2 minus G2. But the second one will be different. Second one will become E3 minus G3. That's not what I want. I want them to always minus this one. That's the mean. Okay. So how to do that? That's the mean. So you have come to the formula here. You put a dollar symbol in front of the row number. Shift 4. That's a dollar symbol for most keyboards. Okay, shift. So once you put dollar symbol in front of the row reference, that reference will be locked. So when you copy this formula into other cells, it will not be dynamically changed. Okay. So now if I drag this, if you hover at the bottom right corner of the formula in my F2, and then drag to the other rows, they all refer to G2. Double check, always double check the formula. Okay. Okay. Now we call this one deviation. If you just calculate the average of deviation, it's always 0 because they always sum up to 0. You see, the average is always 0. The sum is 0 because the average, the mean, is the average of difference. Average of the original values. And then you take the deviations. The average of deviation is always mean. It's always 0. Okay, because the sum of deviations is always 0. Okay, so how to quantify this average level of deviations? You can square them. You can square them, okay? You can square each of them. So shift 6, the little hat is to the power of 2. You can square them, okay? After squaring them, you take the average. The average of square deviations is equal to the variance. The average of square deviations from the mean is equal to the variance of the data. So it should be 19.4. These two values are the same. So now we know the meaning of variance. It's just the average of the square deviations from the mean. And then you take the square root of variance, you get the standard deviation. So no wonder if people ask you, okay, what does standard deviation mean? It's hard to say. It's a formula behind it. So if I assume you learn some statistics in your high school or university, and then you should know what I mean. Otherwise, I have to spend like half an hour to explain it to you. And then in a common language, you can just say the average level of variability or variation. We can call this one standard deviation. We can say standard deviation represents the average level of variability or variation. Because if all the values are the same, if people are of the same heights, then the deviations will be 0, 0, 0. Then the variance will be 0, and the standard deviation will be 0. That means there's no variation. Okay. If the people are very different in terms of height, then the variance will become bigger, and the standard deviation will also become bigger. So we can say standard deviation represents the average level of variability from the mean. Now, you may ask me, why don't we just calculate the average of the absolute standard deviation? Okay, why don't we do that? Yes, we can. Okay, it's called a mean of absolute deviation, MAD. I think Excel has a function for that. Maybe not. I think Excel has a function for the MAD. Maybe I forgot. I can double check. You can double check for yourself. But if I do manually, I can calculate the absolute value of this deviation column and then take their mean. So how do we do that? Let me. Okay, this chance to show you something cool. So how to get the absolute value is called the ABS function. Return the absolute value. Okay. So if I use ABS function and I highlight this whole column of deviations and then enter, I will get a column of absolute values. Sorry. Okay. And then what I want is the average, the mean of this column of absolute value. So I just go to my first formula. The first cell, I have a formula. I put this absolute values of column into a bracket, and then I type average in front of it. Now I will have only one value. That's the mean or average of the column of absolute values of the deviations. 3.52. That is the average absolute deviations from the mean in my original data set. The 5 people's heights. But I think Excel has a function for it. Maybe not. I don't know. Maybe not. I don't know. Deviation. It's called the deviation. This one. Yeah, I found it. AVE-DEV. That returns the average of the absolute deviation from the mean. AVE-DEV. I need to highlight the original data, right? Not deviation. Highlight the original height. AVE-DEV, that is the average deviation, absolute deviation. It should be 3.52. Yeah. Most people probably don't know this one. But again, if you do it manually, it's not too hard. Average absolute deviations. Okay, let me show you something cool. Okay, if you notice AVE-DEV, that is the average mean. Sorry, the average absolute deviations from the mean. If I do it from scratch, I need to do this. The average of absolute deviations from the mean. If I use my raw data, that will be this heights minus the average of these heights. I need one more bracket, I think. So that's how I do it if I have a raw data. So first of all, I need to calculate the deviations at the mean of the range, E2 to E6, and then calculate the deviations, and then take the absolute values and take their mean. Wait. But this long formula can be replaced by this one, AVE-DEV, average deviation. Probably most people don't know this one. But I think this one is easy to interpret. Okay, in practice, if you want to quantify the average level from the mean, you can use AVE-DEV. In other books, it is also called MAD, mean absolute deviations. Don't call it MAD. It's MAD means mean absolute deviation. Okay, in Excel it's called in Excel the function is AVE-DEV, average deviation. I think they should change it to MAD. MAD is easier to remember. MAD. Yeah. But in academics papers or research papers, we use standard deviation much more often than the math, because standard deviation is related to variance, which is further related to other statistical procedures and formulas. Okay, yeah. So if you're studying finance or economics, we use standard deviation very often to quantify things. In finance, we use standard deviation a lot to represent something called risks or fluctuation in finance. Risk fluctuation. Yeah. All right. Okay, let's talk about a few more, and then we can conclude. So we know the mean, the median, the mode, the range, the standard deviation and variance. To understand standard deviation, you have to understand variance first. And then we talk about MAD. In Excel, it's called the average deviation, the mean absolute deviation from the mean. How about the quantiles? So we know the data. This is data. Let me highlight them. The number color in red. We can get the central value. How about we divide our data set into portions, and then if we know the dividers values, and then we know the general spread of my heights, the heights in my class. Okay, so median is one divider, which divide the whole data set into two halves. How about we divide the data into 4 quarters, or 4 portions, equal portions? So to divide something into 4 portions, you need 3 cuts, right? 1, 2, 3. Just think about a loaf of bread. If you want to divide into 4 portions, you need 3 cuts, right? 1, 2, 3. So in statistics, same thing. I have a 1 column data or 1 set of data. After sorting them from smallest to largest, using 1 cut, I can divide that into 2 halves. We call that one median, 2 equal halves, right? Lower half and upper half. And then for each half, I have a one. I can also calculate their individual median. Okay, so I can have a half of the lower half. We call that one the first quartile of the original data set, and then the divider of the upper half, we call them Q3, the upper the third quartile of the original data set. So by using quartile, the 3 quartiles, I know the 3 dividers of my data set. So 1 quarter, so let's calculate them. So the function is called quartile, QAR quartile. Again, you have 2 options. They are slightly different in the algorithm, but it doesn't matter if you have a larger data set. Okay, so I like to use the first one, the EXE one. Okay. So again, if you have like more than 10 or 20 observations in your calculation, then the 2 formulas return almost the same thing. I like the first one. So quartile can calculate the 3 quartiles for you automatically. So you have to tell the function what is your data set. For me, it's E2 to E6. And then comma, you have to tell Excel which quartile you're after. We have 3 quartiles. If you want the second quartile, which is the median, you put 2 here, which we know will be the median, 173. Okay. If you want the first quartile, you put a 1 there after comma. Get the first quartile, 168. And for third quartile, you put a 3 there. You put anything else, you get error. You put a 5 here, number error. Okay, yeah. So again, for this toy example, it's kind of unnecessary. But if you have like more than 5 numbers, 50, 500, then the quartiles can tell you the locations of your data set. Okay, so 25% of my observations are lower than first quartile. Right? That's the meaning of quartile, right? And then 25% of my data are higher than the third quartile. Right? And then the difference between the first quartile and third quartile, that's half my data set. Half of my data is in the middle between the first quartile and third quartile. That thing's called the IQR, interquartile range. The difference between Q1 and Q3 is interquartile range. Again, Excel don't have a formula for that, but we can calculate the first quartile and third quartile separately and take their difference. Interquartile range is also used a lot in academic papers. Okay, interquartile range. Okay. Because range is sensitive to extreme values, but interquartile range is more robust. Okay. It's not easily affected by extremely large or extremely small values, right? But the range is. Okay, yeah. So, all right, quartile, interquartile range, and then so once we know quartile, why don't we go a bit further? We divide the data into, let's say, we divide them by 100 portions into 100 portions. Okay, then we get percentiles. Okay, if you divide a data set into 100 portions, you need 99 cuts. Right? Remember, if you divide it into 4 portions, you need 3 cuts. We have 3 quartiles. If you want to divide your data set into not 100 portions, equal portions, you need 99 cuts. So we have 99 percentiles. Again, how to calculate percentiles? Again, very easy. We have a formula in Excel called a percentile. Again, 2 options. They are almost the same. We have a large data set. So I like to use the first one, EXE formula. Percentiles. Again, you highlight the data set. And then you tell Excel which percentile you want. But again, don't use 1 or 2 or 3 or 99. You have to use decimal. So the 10th percentile will be 0.1. 0.1. You put 0.1, that will return the 10th percentile. Okay. If you put we get error here because we have only 5 numbers. The data set is too small. Yeah. The EXE algorithm will not run for a small data set. Because we don't need this kind of summary statistics for small data set. Remember, the purpose of this statistics, all the formulas matter, is to summarize information from a numerical variable to get their insights. For 5 numbers, I don't need any insights. I can read them out for you one by one. Okay. Summary is for summarizing things. For 5 numbers, I don't need to summarize. My little brain can handle it. Okay. But I just tell you to use the formula percentile. You put a decimal here. The value here has to be between 1 and 0 and 1. If I want 99 percentile, I put 0.99. If I want 80th percentile, I put 0.8. If I put 0.5 here, I will get the median. That's the 50th percentile, right? Which is the median. Okay. Yeah. All right. So that's percentile. So again, are they useful? Again, it just helps you to get insights from the a list of numbers. Okay, you know their central locations, you know their spread, and then you know the spread over the range, like by using the quantiles. And the last one before we finish, I want to tell you something else. It's called percent rank. I don't know if you know this formula or not. Percent. This one. Percent rank. Percent rank. What percent rank is related to percentile? For percentile is, okay, I have a set of data like this 5 heights. And then I want to know for a percentage location, what's the value, right? So for this data set, what's the 90th largest value? That's 90th percentile. Okay, or 90% of the data set is below the percentile. But if you think about this one in the other direction, give the data set, and then I want to know the position of a specific value, I can use this percentile rank formula. Okay, so again, just ignore that for a moment. So for percentile before, this one, I have my data set from E2 to E6, and then I want to know a value given the percentage location, like 0.5. That's the middle position, and the percentile will return a value. Now, if I change my question, given a data set, same data set, and then I have a value. I want to know for this value in this context of data set, what will be this value's percentage value position? That is what the percent rank function does. So okay, for this context, for these 5 students here, for their heights, if what will be my percentage location? My height is 182. This percent rank function will return a percentage value. Okay, you can also request decimal. I want 2 decimals maybe. Again, it's too small. Let me 17172 176. We have a small data set, have this kind of a problem. Okay. So again, this formula here. For this data set, in this context of E2 to E6, if your height is 175 centimeters, then the percentage rank is about 82%. You understand what it means? That means for this context, in this data set, a value of 175 is sitting at about 82%. That means taller than 82% of the set, and shorter than 80% of the remaining individuals. Okay, yeah, that's the function of percent rank. And then if I can request 2 decimals, I can request 1 decimal or no decimal. I think if you don't put any decimal, the default is 3 decimals. Okay. Yeah. Again, the return will be somewhere between 0 and 1. They tell you the percentage location of your value given the context of your data set. I think this one is also very useful, but I don't see that very often people talk about it in the textbook. But in practice, I think could be useful, right? If you're if you are do some analysis for some real estate agent for your hobby or for a very casual job in the weekend, you can calculate the percentage location of the price of some property in the local market. Okay, for this 100 houses on the market in this suburb, what will the location for your house on the list you want to list on the market? Okay, maybe it's at 82%. That means more expensive than the remaining 82%, and then cheaper than the remaining 18%. Okay, remember the function name, percent rank. Okay, which is kind of sister function of percentile. That's enough for today. I think almost 8:20. Any questions you want to ask me before we leave? Oh, the online person still here. That's good. Any questions you want to ask me before we conclude? People in room? All good? You learn something useful? Something useful? Something interesting? Okay, thank you. Yeah. Yeah. Excel is very useful. It's kind of it's not a special software for statistical analysis. We have a more powerful like Stata, SPSS, the packages in R for free. They are special packages for statistical analysis. But to be honest, for office workers who deal with data some every day or some days of the week, Excel is the most commonly used and the easiest one to use for day-to-day jobs. And everything we need to know how to use it properly. Like those functions like this percent rank, and then also this like AVE, DEV, those kind of things you probably know know them, but how to do them in Excel is very easy. Just one click. Okay, one click. All right. It's good to learn the stuff if you have a real problem. If you have an assignment or some project, and then if you can learn how to do them, finish them in Excel, that will you probably remember them forever. But that's anyway, that's teaching and learning. Okay. Any question for the online person? Oh, good. Okay. Okay. I'm going to stop recording now, and then I'll stop it. Anyway, it's frozen. Come on. Yeah, thank you. What's wrong with my laptop?